Hello, AB Calculus students. Let's get ready to do one more day here in 7.3 with our integration by parts. So we're continuing on with what we've been looking at in the last couple times. So let's look at the following situation. This is a new situation that we haven't seen yet. So we have this integral here. We have e to the x cosine of 2x dx. And we notice that this is one of those where a trig function or an exponential function, either one can be a choice for your u and either one can be a choice for your dv. And so it really doesn't, the key is whatever you pick for your u, you are going to have to differentiate. Whatever you pick for your v, you will have to integrate. So I can let the e to the x be the u, or I could let the e to the x dx be the dv. Or I could let the cosine of 2x be the u, and then or I could let the cosine of 2x dx be the dv. Which one to choose? That's the question. You can do either one. You'll get the same answer either way. But here's my suggestion. It's easier to take derivatives than it is to integrate. So I always pick the easier function to be the one that I'm going to integrate. So since this is going to take a little bit of chain rule if I differentiate or use substitution if I integrate, it's going to be easier to differentiate this and integrate this. So I'm going to let my dv be e to the x dx, and I'm going to let my u be cosine of 2x. So here I'm going to select my u as the cosine of 2x, which makes my du, when I take that derivative, negative sine of 2x. And then my dv becomes e to the x dx, and that makes my v just e to the x. So I think that's easier to integrate this one and do it that way. But you could do it the other way. So let's go ahead. Now let's apply our integration by parts formula. So we have this expression right here is equal to u times v. So here's our u, here's our v, and we'll probably write it with this in front. That's the way we're used to seeing it. Minus the integral. So now I'm going to put down my integral, and I've got v du. So here's my v. Here's my du. So I will probably put that negative 2 in front there and write it like that. Now, I could go on here, but probably best to actually take the time to write this, factor out the negative here if I want to do it that way, or also I could factor out the negative 2, and that's what I did, is I factored out the whole negative 2 here. And unfortunately, if you notice here, this really isn't any simpler. We're really not any closer to having something we can integrate than we were here. But it also hasn't gotten any worse. So we're going to take advantage of that, and we're going to do this process again. So now I'm going to look at this integral here, and I'm going to do integration by parts on this integral right here. Once again, I'm going to let this e to the x dx be my dv, because that'll be an easier integration, and I'll let the sine of 2x be my u, because then that'll be an easier differentiation. So u is my sine of 2x, makes my du 2 cosine 2x dx, and there's my dv and my v. So now I'll go ahead and I'll apply this again. So now I know that this up here is equal to, and I'll rewrite, so I start off with e to the cosine 2x plus 2 times, now here's where you got to use your parentheses, be careful, parentheses. Now this integral becomes, using my integration by parts, it becomes uv, so it becomes e to the x sine of 2x minus the integral, and now it's v du, so it's the integral of e to the x. So there's that factor of 2, like that. And what I'm going to do here is I'm going to go ahead and I'm going to distribute this 2 through and factor this 2 out. And so look what I end up with. Now, here's where I got to remember, I actually started with this. Remember, it's this that's equal to this. So writing this out, just copying this down here, distributing this 2 through, minus bringing the 2 out and distributing that 2 in, I get this. Well, you say, I haven't accomplished anything. I'm right back to where I started. And you're right, I am right back to where I've started. I have the integral of just what I started with. But I'm going to use that to my advantage. Because remember, I'm trying to find out what that is. So I'm going to take, I have this equal to this whole thing here. So I'm just going to go ahead and I'm just going to add, since I have minus 4 of these integrals, I'm going to add 4 of these to both sides. Notice this is what I have on this side. So now what I get is on the left side, I get 5 of these integrals are equal to this expression here with no integrals. And now all I have to do to get this integral by itself, divide by 5 or multiply by 1/5, and I get my expression. I do have to tack on my plus c. This is going to be 1/5 by the whole thing there times the whole thing. I could distribute it if I want to, but it's not necessary. And so now I've got my answer. So that's a process and usually you have to do it when you've got exponential times trig, but not just that. Sometimes it actually has to come in place when you have trig times trig. Sometimes you have to go through that. Just recently we were doing that in a BC calculus problem. So it is important you recognize how to do that. All right, one more skill to learn when we're doing integration by parts is how do we handle definite integrals. So we haven't talked about this yet when we have limits of integration. So let's look at that. So doing this here, this is a classic situation that requires an integration by parts. Now, before when we did these things, when we did u substitution, after we did the u substitution, at the same time we did that, we then changed our limits of integration to match our u substitution. This time we're not going to do that. This time we're going to change it. We're going to do our integration by parts, and then we're not going to change any limits of integration. So even though we have a u and a d and a du, we're not going to change anything. So here's our straightforward setup. We know we want our u to be x because when we take the derivative it gets simpler. Sine, when we integrate that, doesn't get any more complicated. So sine x dx, when we integrate it, we get negative cosine x. And there's our du becomes our dx. So now we can go and re-express this. Negative x cosine x, that's our u times v, minus the integral of our v times du. So it's these things multiplied together. So it's negative cosine x dx. Factor out that negative, make that a plus, and then integrate cosine. And that just becomes sine. But now once we get to this, we have to evaluate, it's not just this last integral that we did, it's this whole expression that's equal to that integral there. So we have to evaluate the whole expression from 2 pi to pi. So we put the 2 pi in here first and go ahead and evaluate. So when I put 2 pi, the cosine of 2 pi is 1. So this is negative 2 pi times 1, which is negative 2 pi, plus the sine of 2 pi is just 0. So that's that negative 2 pi times 1 minus, and the sign of plus, that's 0. And then we have minus. So when I put this in, putting this in, this becomes, you want to be careful with your negatives. This becomes negative pi times negative 1. So we have negative pi times negative 1, and the sign of pi is 0 again. So being careful here and distributing through, it looks like I get negative 2 pi minus pi, so it looks like my final answer is negative 3 pi. So in this situation, they actually wanted the area. So the area would be a positive value, it would be 3 pi. We get negative value for our integral because it was below the x-axis in that context there. Okay, I think that should get you guys set. Your homework is going to be 17 and 20. Those are going to be 2 of the integration type where you have to go until you get back to the integral you started with and then solve for it using some basic algebra. And then 25, 27, and 35 are going to be definite integral type problems. Okay, hope it goes well. Hope you guys have a great weekend. And on Monday, we'll talk a little bit more. We may have one more day here with integration by parts, but then we'll be, it may just be on Monday. We're just getting ready for the final. All right. Talk to you later.